A1P2CP. Today we're starting our last section of the unit. This is a really quick unit on inequalities. And like I said in my last video, we are doing systems. So now we're going to take what we know about just graphing a regular linear inequality and graphing a system, which really just means we're going to graph two lines and see where their shadings cross. So remember from last week, if it is a greater than or less than symbol, our line is dotted. And if it's greater than or equal to or less than or equal to, it's a solid line. So let's jump into number 1 and number 2. They're both going to be in standard form. So I'm showing you 2 examples with standard form, which is just like your homework tonight and tomorrow. 2 with standard, 2 with slope-intercept, and then we will be moving on Wednesday. So let's look at this line, these 2 lines here. So in standard form, remember when we learned this way back, probably in February, we asked you in standard form to find the intercepts. So this first equation, I'm really thinking of that as 6x minus y equals -3. Okay, so if I'm going to find my y-intercept, I cover up the x. I have -y equals -3. Okay, so for the y-intercept, I have -y equals -3. So divide by -1, and that means y equals 3. So I have the y-intercept at 0, 3. The x-intercept, I cover up the y, and I have the equation 6x equals -3. I divide both sides by 6. -3 divided by 6 is -1/2. So I have the x-intercept at -0.50. So for this graph, I'm going to go and plot the point 0, 3 and the point -0.50. This was a less than problem, so that means it's dotted. So here I am, I should probably use a ruler. Okay, this is fun. Wish I had a third hand. Okay. Alright, so Alright, not the best, but better than if I freehanded it. Okay. I'm also going to figure out my shading right now. So does this line go through 0, 0? Nope, it does not, so I can test 0, 0. So I'm putting 0 in for x and 0 in for y. So I get 0 is less than -3. Is that true or false? You're going to tell me that is false. So because 0, 0 lies to the right of this line, I shade to the opposite side because my statement was false. Okay, so there's line 1. And that's basically what we did last week. Now we're just graphing 2 lines. So I'm going to do my other line in this green teal color. I'll have it color coded for you. Whoops. Okay. So same deal. It's in standard form. I'm going to do my intercepts. So for my y-intercept, I cover up the x, and I'm solving -y equals -1. So that means y equals 1. I have the y-intercept 0, 1. For my x-intercept, I cover up the y, and I have, remember, really the equation, because we don't look at the inequality till later, 6x equals -1. To solve for x, I divide both sides by 6. I get x equals -1/6. And that's okay that it's a decimal. I'm going to try to get it as close as I can. Alright, so I'm going to go to 0, 1 and put a dot for my y-intercept. And then to -160. Remember, this was -1/2. And I know you can put that in your calculator, but -1/6 is smaller than -1/2. So it's going to be somewhere here. This line is solid. Okay. And so okay, whoop. Well, the end got kind of a little messy there, but we got it. I'm also now going to figure out the shading of this line. 0, 0 is not part on this line. No, it might look like it, but remember, that's really close. So I'm going to test 0, 0. So it means I'm putting 0 in for x, 0 in for y. And so is 0 greater than or equal to -1? Yes, it is. So that means I shade on the side that has 0, 0 on it, which is to the right. Now I have a lot of colors going on here. and my graph is blurry. I'd like us to just stop and look at these two lines for a second. So I know my teal one is poorly drawn here at the end. If I could just make that a little straighter, that would be cool. So what I want you to think about is, are these two lines parallel? And this goes back to February when we looked at this unit before. And just really quick as a side comment about the slopes of these two lines. I remember Luke and Tim helping me out with this in class, and Nate, how to find the slope of a line in standard form without doing any work, remember, is negative a over b. And that comes from ax plus by equals c. So in that first equation, your a is negative 6, it's 6, but I have to make it negative, and my b is negative 1. So my slope of that first line is 6. Look at your second line. Hey, my gosh, it's the same thing. It's going to be negative 6 divided by negative 1 at 6. The slopes are the same. So what does that mean about these two lines? They are parallel. So go back to our graph. Is the purple and the teal ever going to cross? The answer is no. So this teal one is always shaded down and to the right. This purple one is always shaded to the left. Now, when we have a system, the answer is where the two colors or the two shadings cross. So, does this problem actually have any solutions? Meaning, do the teal and the purple ever cross? The answer is no. So my answer to this one is actually no solution. It could never be true. These two lines, the shadings are never going to cross. Now that doesn't mean if you have two parallel lines, it doesn't mean that this is always what you're going to see. In my next example, you're going to see a different situation. Okay, but I thought this was a good one to go over. I know these videos are a little bit more lengthy today, but some of you have been asking for more problems. So I'll try to make it a little bit quicker. So my second standard form problem is this one right here. All right, so again, we'll do it by colors. So I'm going to do it by intercepts because it's standard form. So my first one, if I want to find the y-intercept, I cover up the x, I cover up the x, and I'm solving the equation y equals negative 3. And there's nothing to solve, so I found my y-intercept is at 0, negative 3. Now I'll find the x-intercept. I cover up the y, and I'm solving, gosh, I'm apparently having a hard time here. 2x equals negative 3. Divide both sides by 2. You're going to get x equals negative 3 halves. And I know some of you prefer decimals, that's negative 1.5. For some reason, I don't have my graph pre-made on this one. Okay, 1, 2, 3, 4, 5. See, I don't have graph paper either, so no worries. If you could try to use some sort of a straight edge, even if you don't have a ruler, you can use the side of a paper. Okay, so my y-intercept for the first one is at 0, negative 3. You might say, Mrs. Swanson, I'm seeing that these two are the same. Isn't this going to be like the last one? The answer is no. So hold on with me for a minute. The x-intercept is at negative 1.50. This one's going to be, come on and focus, solid. Bear with me as I draw my line. Okay. Now we'll test out the shading. It does not go through 0, 0, so I can test 0, 0. So I'm putting 0 in for x, 0 in for y. Is 0 greater than negative 3? Why, yes it is. So that means I'm going to shade on the side that has 0, 0, which in this case is to the right. Okay, next line. Y-intercept. I cover up or put 0 in for the x. I have y equals 1. This one has a y-intercept of 0, 1. Remember, that was the equation there. My x-intercept, I cover up the y. I'm solving 2x equals 1. Divide by 2. I get x equals 1/2. Okay, so this one has a y-intercept at 0, 1. It has an x-intercept at 1/2, 0. It is also solid. Again, this whole section is basically like what we did last week if you're not catching on to that. So now I have to test. I can test 0, 0. 0, 0 is not on my teal line, so I'm putting 0 in for x, 0 in for y. Is 0 less than or equal to 1? The answer is yes. So that means I shade to the side that has 0, 0 on it, which in this case is the left. So, hey guys, are these two lines parallel? Not just because they look like it, but stop for a minute and look at the slope. Remember, it's negative a over b. The slope of that first line is negative 2 divided by 1, which is negative 2. The slope of the second line is also negative 2 over 1. So again, the slopes are the same. These lines are parallel, but here's a different situation. Where do the two colors overlap? My purple and my teal, they overlap in between the two lines. So my solution to this problem is the graph, and it's the shaded area between the two lines. Also, any point on either line, because they are solid, would be a solution to this system. So solution. Remember we talked about that last week, where with a dotted line, points on the line are not solutions. With a solid line, points on the line are solutions.